Okay, Math 7, we are going to run through your quiz review. So in the first part of this chapter, we have been covering proportions and ratios and unit rates. And so we'll just do a few different examples. So the first one, in 2007, the record for the University of North Carolina softball team was 46 wins to 21 losses. Write the ratio of wins to losses in all three forms. So they want wins to losses. So putting it in words is really useful because that sets it up for you, shows you which order they have to go, because the order is very important when we are setting up proportions. So 46 to 21. You kind of want to check maybe, see if you can simplify them. 2 can go into 46 and not 21. 3 can go into 21 but not 46. 7 can't go into either one of them. So this is the simplified version. The other way we can write this is with a colon and with the word 2. Those are the 3 ways that we could express the ratio of wins to losses. Number 2, the concession stand sold 14 strawberry, 18 banana, 8, this is supposed to be grape, 6 orange fruit drinks during a game. Tell whether the ratio of strawberry to orange, so strawberry to orange, or banana to grape. Okay, so strawberry was 14, orange was 6, banana was 18, and grape is 8. So remember here that you can't make a comparison unless they have the same denominator or until they're reduced all the way. So if we want, we can simplify these first. This would be 7 to 3, and this is going to be 9 to 4. Now, it still might be hard to make this comparison. So if we are finding a common denominator, we know they both can go into 12. So I know it's kind of funny to reduce them and then make them bigger again, but let's multiply these both by 4 and these both by 3. So this is going to be 28 twelfths, and this is going to be 27 twelfths. So who is bigger? Who is the greater ratio? And that would be strawberry to orange. So remember, it's kind of like comparing fractions. Okay, the next ones, we are finding the unit rate, and I said round to the hundredth if necessary. We are gonna, I am gonna let you use a calculator for some of these unit rate. When we start dealing with money, it is harder to do them by hand. So the first one, we want to know how many dollars per square feet. So we would take 140 and divide it by 18, and that gives us 778. Remember, when you round, if you look at my decimal and you cut that off, the 7 makes the other 7 go up. So it's 778 per square foot. Make sure that you label that. 346 divided by 22 would give us 15.73 miles per gallon. So that would be kind of like telling how many miles per gallon your car would get. And the next one is pounds for $2.99. Now this one, they kind of switched this around. Now we are going to want to find out the dollars per pound, because it would be weird to find pounds per dollar. So I'm going to take $2.99, I'm going to divide it by 14, and I arrive at 21 cents per pound. So whatever they were selling was pretty reasonable. So one other thing when we find the unit rate, a lot of times they tell you which one you should divide by the other. A lot of times time is going to be on the bottom and money will be on the top. Those are a couple like standards. So this one's miles per hour. So I'm going to set it up 621 miles per 11.5 hours. 621 divided by 11.5 is going to give us 54 miles per hour. So that would be the average speed that Shanti traveled. A grocery store sells a 7-ounce bag of raisins for $1.10 and a 9-ounce bag for $1.46. Which size bag has the lower, and they give it to us right here, the price per pound? So we want to know dollars per pound. So I'm going to do the $1.10. Oh, per ounce, sorry, $1.10. And then it's 7 ounces. And then my other one was $1.46 for 9 ounces. So then we're going to just take and divide those. 110 divided by 7. And it's money, so we're going to go to 2 decimal places. So this is 16 cents an ounce, 0.16 per ounce. And then the other one's $1.46 divided by 9. And that one's going to give us 0.16. I'm going to have to show you guys this because this one goes like this. And this one, before we rounded, was 157.1. So these ones actually, even though they both round to 0.16, if we were being very technical, this one would be cheaper. But when they're rounded, they both are the same. So I would accept either answer in this case. I would accept they are the same when rounded, or you could tell me that the 7 ounce is just a tiny bit cheaper. Okay. Number 6, A, B, C, and D, you could have different answers than I do because your job is to find a ratio equivalent to each ratio. Now, we've talked before about how there are lots of different options. I'm just going to do a couple for each one. So, for example, this one, I could reduce them. So I could divide them both by 2, and I could get 5/8 equals 10/16. I could take and I could times them each by 3, so I could get 30/48 equals 10/16. There's multiple ways to do that. On the next one, I could divide them both by 7, and I could get 3/4. I could times them both by 2, and I could get 42 56s. Had to think there for a second. The big thing is when you write a proportion that it has an equal sign there. And then 12/25. Well, that one I can't simplify because nothing goes into 25 and 12, but I could double it or I could triple it. So let's triple it. If you take 12 times 3, you get 36. If you take 25 times 3, you get 75. You could times it by 4. So 12/25 is the same thing as 48/100. Notice I did the same thing to the top and the bottom. And the last one here, you could have maybe divided by 4. So if you divided by 4, you would get 10/12. Maybe you decided to divide it by 8. If you divided by 8, you'd get 5/6. You guys might notice too that when you take 10/12 and you divide it by 2, you get 5/6. So like these are going to be equal if they're equal to the first ratio that they're given. Okay, so lots of different choices. I just did a couple. Steve was able to assemble 247 parts in 19 minutes. Larry was able to assemble 333 parts in 22 minutes. Are their assembly rates proportional? So one thing that we talked about is that in order to be proportional, they have to be equal. So let's do Steve's. He was 247 to 19 minutes. Let's get a unit rate here then. So we need to take 247 divided by 19. And if I do that, I get 13 parts per 1 minute. So then Larry, he was assembling 333 parts in 22 minutes. And remember, to get a unit rate, you take and divide both the top and the bottom by 22. And I do get a decimal here. That's okay, though. 15.14 parts per minute. Now, the only thing, they didn't ask who was faster. They just asked, are they proportional? And we know that they are not. One other way to solve this problem would be to set it up in a proportion. 247 over 19, and then 333 over 22. Now, in the last section in 4.4, we learned that cross products have to be equal in a proportion. So you could take these products and you do 19 times 333, and that gives us 6327. And then we could take 247, because then these ones are going to be equal, times 22, and you get 5434. So they are not equal, so they aren't. So cross products are not equal, so they are not proportional. Okay, that was one other little thing that we talked about. Okay. Number 8, on a given day, the ratio of dollars to euro, so they give you the order, so it's really important to pay attention to that. We have dollars to euros was 1 to 0.735. So that means a euro was worth a little less than $1. Then they said, is the ratio 20 to 1470 an equivalent ratio? And explain. A couple different ways to do this. The easiest one probably is to use cross products. So we're going to multiply. So 0.735 times 20. And when I did that, I got 14.7. Well, 14.7 times 1 is 14.7. So is the ratio equivalent? Yes, because when put into a proportion, the cross products are equal. Okay. Number 9, we have some different problems where we're going to solve proportions. Now, the way that I told you about it, we could use cross products, and you can set up a little equation. 8 times 15 equals 4 times n. 8 times 15 is 120. Last step would be divide by 4, and we get 30. Okay. The other way to solve is, I always say, you multiply the two numbers across from each other. So 15 times 10. And then you divide, and I call it the odd guy out. He's the guy over here without a partner. So 15 times 10 divided by 24, and we end up with 6.25. Now sometimes, like I'm just kind of glancing back at letter A, you might notice like 8 is twice of 4, so 30 is going to be twice of 15. So you might be able to look at it and figure it out, but sometimes you can't. Like on letter C and D. So we're just going to multiply the two numbers that are across from each other. 84 times 32.5, and then you divide by the odd guy out. Divided by 182. We get R equals 15. Now that I let you guys use a calculator, these are a piece of cake. And then divided by 76. And K would be 324. Okay. Number 10, it says you can find your distance from a thunderstorm by counting the number of seconds between a lightning flash and thunder. For example, if the time difference is 21 seconds, the storm is about 7 kilometers away. So this is where we're going to set up a proportion. Our ratio is every 21 seconds, the storm is 7 kilometers away. Notice how I labeled those. So then it says about how far away is the storm if the difference is 9 seconds. So we are going to leave this to solve. 9 times 7, 63, divided by 21 is 3. So that would be 3 kilometers, because that's what we were talking about. So proportions are really useful to help us solve all sorts of different problems. Big takeaways: labeling, pay attention to how the question is worded, and we are starting to be able to use calculators.